All right, let's keep going on this. I did recognize that I lost my 2 here, so I'm going to have to squeeze this in. This would be 2a change of x squared plus 6c. All right, so this is the area underneath any parabola from negative change of x to change of x. Now, I'm curious a little bit more about these y values. We said these y values are going to end up being important. So what are those y values? Well, y sub 0 is going to be what we get when we substitute negative change of x into our function f of x, which is ax squared plus bx plus c. Let's see what all 3 y values are. So let's start with y sub 0. That's going to be f of negative change of x. Okay. And when we substitute that in, we get this, which is equal to, well, when we square the negative, it's just a positive, so a change of x squared. That negative is going to make this a minus b change of x plus c. All right, so there's y sub 0. Well, what's y sub 1? Well, y sub 1 is going to be f of 0. And when I put 0 into my quadratic, I'm just going to get c, right? The ax squared and the bx are going to be gone. Now, how about y sub 2? Well, that's going to be f of change of x, which is a change of x squared plus b change of x plus c. Now, what do you notice about this and that? Okay. Well, we notice that they are the same, except this negative b change of x and the b change of x are opposite, so they would cancel each other out if we added these together. So if I take y0 plus y2, what do we end up with? We end up with 2 change of x squared, the change of x terms are gone, plus 2c. Now take a look at this and take a look at that. Oh, I lost my a. Now this is going to look better, isn't it? There we go. So 2a change of x squared plus 2c. Here we had 2a change of x squared plus 6c. They're awfully close, except this has a 6c and this has a 2c. Could I make this equal to what we had before? Well, I could do that if I added on 4 more c's. Well, if I'm adding on 4 more c's, hey, how do I get that from my y0s, y1s, and y2s? Well, y1 is c. So adding 4 more c's on is really like we're adding 4 y1s to both sides. So we end up with this. I'm going to rewrite this in a different order here. Y sub 0 plus 4y sub 1 plus y sub 2 equals 2a change of x squared plus 6c. Now that's a big deal for us, because remember that this is the area under any quadratic from negative change of x to change of x. But now we know we actually don't need the a and the change of x and so on. We can replace that with what it's equal to, which was y sub 0 plus 4y sub 1 plus y sub 2. So the definite integral from negative change of x to change of x of any quadratic is equal to this. Oops, there we go. Now I don't have 2 equal signs. Okay. Which is really cool. So now, as long as we know what change of x is, and we know the 3 y values of our points, we have the area. That's pretty fascinating. Okay, and that really is helpful. So this area underneath this curve, okay, is equal to 1/3 times whatever our change of x is, that in this case it would be 1, times y sub 0 plus 4y sub 1s plus y sub 2. All right, so that's the area under one of these parabolas. But now what we're doing is we're stringing all of these parabolas together. So this is here. This would be y3, this would be y4, y5, y6, y7, and y8. So what's going to happen when we add all of these together? Okay, and that's my next question here. Oops, well, I guess see the previous page. Okay, we already wrote that down. That's this right here. No, I guess it's not it's somewhere. There it is. This is the area under the quadratic. All right, so what will this look like if we do it for the next 3 points and the 3 points after that, and we add all these areas together? So we end up with this. Well, for the first one, we already have that. It's 1/3 change of x times y sub 0 plus 4y sub 1 plus y sub 2 plus. Now we have to go to the next one, which is going to be the same, except now our first point in this set of 3 points isn't y sub 0. Let's look back at our drawing here again. When I look at these pink dots, my next 3 points for my next parabola, the first one isn't y sub 0, it's y sub 2. So this is going to be y sub 2 plus 4y sub 3 plus y sub 4. So 1/3 change of x, y sub 2 plus 4y sub 3 plus y sub 4 plus. Now we do the next one. 1/3 change of x. What's the first y value that we're going to use? It's actually the same as the last one we used in the previous interval. Again, looking back at our diagram, we start our next interval with these green points. And the first one on the green points is y sub 4, the last one on the previous parabola. So this ends up being y sub 4 plus 4y sub 5 plus y sub 6. And we're going to continue to do that till we reach the end. Now let's look to simplify this a bit. Well, notice each one of these terms has a 1/3 change of x in it. So let's factor that out of everything. That leaves us y sub 0 plus 4y sub 1 plus y sub 2 plus y sub 2 plus 4y sub 3 plus y sub 4 plus y sub 4 plus 4y sub 5 plus y sub 6. And that is going to continue on in that pattern until we get to the end. Now, do we have some like terms here? And the answer to that, of course, is yes, we do. Now, this is the only y sub 0. This is the only y sub 1. But how many y sub 2s do we have? We have 2 of them. How many y sub 3s? We have 4. How many y sub 4s? We have 2. How many y sub 5s? 4. How many y sub 6s? Well, we didn't continue this on, but wouldn't the next one here be a y sub 6? So we'd have 2y sub 6. We would have 4y sub 7s, and that would continue on. Do you see a pattern here? And the answer to that, of course, should be yes. Okay. So, if we can know the y values of all the points that we're using here for our parabolas, we can find the area, and that is pretty neat. Okay. So what I've done here is I've written out our Simpsons rule for our approximation for a definite integral from a to b of f of x dx. Okay. It is approximately change of x over 3, right? That was our 1/3 change of x, times Well, we said y sub 0. Well, I'm going to change this to function notation. Y sub 0 is the y value for x sub 0. So that is f of x sub 0. This is our y sub 0. Okay. Plus 4, we said y sub 1s, which is f of x sub 1. And then we said 2 y sub 2s. And these are our y sub 3s, and so on. You get the idea. So we have this alternating pattern. It starts with a 1, then it goes 4, 2, 4, 2, 4, and so on. And then what's it going to end with? Well, if we go to that last parabola at the end, okay, there's going to be 2 of the first y value because it's linking up to the parabola before. There's going to be 4 for the middle one, but the last one doesn't have a pair for the next one because it's the last parabola, so it ends with a 1 f of x sub n, whatever that last one is. All right? Cool. Let's do one. Use Simpsons rule to approximate the definite integral from 0 to 3 of e to the x squared dx using 10 intervals. Now, I want to make a comment about this. This is one of our impossible antiderivatives. It looks really simple, but we can't do it. Okay, this is something that we could try, just a normal substitution of u equals x squared. Can't do it. This is just one of those impossible things to integrate. So we're going to approximate using parabolas with 10 intervals. All right, so going back to our formula, we need to know what change of x is. I know it's been a while, but this should be pretty ingrained into our mind. Our change of x is b minus a over n. So for this one, this is going to be 1 minus 0 divided by 10. Our change of x is 1/10. All right? So this, now let's switch to green. Is going to be approximately 1/3 of change of x, which is 1/10, times. Now, remember, it starts with a 1 f of x sub 0. Okay? Well, this is going to be 1 f of, what is x sub 0? Well, let's kind of write out our pattern here a little bit. Our change of x is 1/10, and we're starting at 0. X sub 0 is 1, or x sub 0 is 0. X sub 1 is going to be 1/10. X sub 2 is going to be 2/10. X sub 3 is going to be 3/10, and so on, right? So this is going to be f of 0 plus, now how does our pattern go? 4 times f of x sub 1. That's going to be 4 times f of 1/10 plus, the pattern then goes 2. Remember, now it's just alternating. 4, 2, 4, 2, and so on. 2 times f of 2/10 plus 4 times f of 3/10 plus 2 times f of 4/10 plus 4 times f of 5/10 plus 4 times f of 6/10 plus 2 f of 7/10 plus 4 f of 8/10 plus 2 f of 9/10 plus, we're on our last one, aren't we? So it should be 1 f of 10/10. But that can't be right. Doesn't our pattern have to end with a 2, 4, 1? So this tells me I made a mistake somewhere in here, and taking a look at it, I accidentally did back-to-back 4s. So this should have been a 2, a 4, a 2, a 4, and then a 1. All right. So this is going to give us 1/30 times, we need to know what f of 0 is. F of 0 is e to the 0 squared, which is e to the 0, which is 1. Okay, and just taking a look at my time, I got to wrap this up. This video, we'll finish this problem in the next video.